Hi, welcome to the Shikong Math Lab. And we talk about in this series is the talk about the calculus in the polar coordinates. And this is the lecture number 3 for this series here. And in this lecture, the part 3, we're going to talk about the tangent line to the polar curve here. Okay, so let's take a look here. So how do we find the slope? In order to get the tangent line, the first things here we need to know is how to find the slope of the tangent lines, right? So we use our basic definition about the x equal to the x equal to the r cosine theta and the y equal to the r sine theta. And then we know the dy dx is the slope. So the dy dx we can rewrite as dy d theta and the dx d theta here, right? Okay. So okay, sorry for here. Okay, so now in here, okay, so in here, let's take a look here. Because dy d theta, in here we know the r is a function of the theta here. So the dy d theta, basically we just do what? We just take the derivative of y, and I'm using the product rule, right? So treat r is a function of the theta. So that's why we have hold the sine theta, take the dr, take the derivative of r, so it's dr d theta, then plus holding the r, take the derivative of the sine theta. So the same way is here. So if you want to find the dx d theta, so it's the same things. You take the derivative by using the what? By using the product rule, right? So that's how did you get the dr cosine theta minus holding the r, then take the derivative of the sine theta will be the negative sine theta here. That's how did you get it. And so also we know the horizontal tangent. What it means the horizontal tangent? That means the slope will be equal to what? Will be equal to 0, right? So I have a fraction dy dx. That means this fraction going to equal to 0. So I know if a fraction equal to 0, what happens here? So we know the top has to be, the numerator has to be equal to 0. That's why we have dy d theta equal to 0. All right, so the same things here. If I want to find the vertical tangent, that means the slope here is what is not defined, right? Okay, so it's not defined. So for when we have a fraction that not defined, what that means here? That means my denominator going to become to zeros, right? So that's why we set the denominator is equal to 0. Okay, so basically this is a pretty straightforward derivative, like how to find the the slope. All right, so let's take a look. Okay, let's take a look at some examples here. All right, so here the r equal to 1 over theta. I want to find the slope when the theta equal to pi here. Okay, so remember we try to do the dx dy, right? So x equal to the r cosine theta and the y equal to the r sine theta here, right? So the x equal to the r cosine theta. Okay, so let's say x equal to the r cosine theta. So what is the r? R here is 1 over theta. So I know the x is what? Is a cosine theta over what? Over theta, right? And so the same way is y is equal to the r sine theta, right? So what is the r again? Is 1 over theta. So I say y, I can say the y equal to what here is a sine theta over what? Over theta, right? Because r equal to 1 over theta. So now I change everything to a function of the theta. Okay, so now let's take a look at the dy dx. Okay, so let's don't try to remember the formula because that's probably will but not be easy to remember, right? So, but then we know this is dy over d theta, and then this is dx over d theta here. So the first one you want to take the derivative of the sine theta over theta. So obviously, what rules we're going to use? We're going to use the quotient rules here, right? Okay, so the quotient rules tell us what is the quotient rules here. I'm going to square the bottom, right? Then I'm going to take the derivative. So the sine theta, I'm going to take the derivative of the sine theta. So what is that? So it will be a cosine theta, right? And then minus, all right? So, and then minus what? Minus, you take the derivative, you hold the top, right? Then you take the derivative about the bottom. So what is that? It will be 1 here. Okay, so that will be the dy d theta here. So dx d theta. So let's take a look. See here, dx d theta, right? So we do the same thing. So you square the bottom, right? So you square the bottom, then you take the derivative of the top. So it will be the negative. Oh, sorry, here we need to times theta here. All right, so we need to times theta here. Okay, so you take the derivative of the top, so it's negative sine theta. Then don't forget times the theta. Then minus, right? So then minus, you hold the top is cosine theta. Then times the derivative of the theta is what? Is 1 here, right? So if you do some algebra to simplify that, so you will find the, so here, if you try to simplify it, and you will find the, this one here will be negative sine theta plus theta cosine theta, and then the bottom will be the negative cosine theta minus theta sine theta, right? So you basically you flip the top, you multiply two fractions, so you just flip the top and then cancel the theta square. All right, so basically in here you can just this theta square cancel, so that's what is your derivative. Okay, so now let's say when theta equal to pi, so what is my slope at this point? So the dy dx will just be negative sine pi plus pi cosine pi. So negative cosine pi minus pi sine pi, right? So the, I know, you know, I know the sine pi equal to 0, sine pi equal to 0, cosine pi is equal to -1. So the top will be negative pi. Then this is negative become 1. So the slope here is negative pi. Okay. Right, so it's pretty straightforward. Okay, let's take a look at the next ones here. So it's the same things here, right? So r equal to the 1 plus 2 cosine theta here. So let's do the same thing with the x equal to the r cosine theta, right? So what is the r? R is 1 plus 2 cosine theta times cosine theta. Am I right? Okay, so the same ones here, y equal to the r sine theta. So you replace the r will be 1 plus 2 cosine theta, right? Sine theta. Okay, so now we do the same thing, dy d theta over dx d theta, and yeah, this one will give us this dy dx as the slope, right? Okay, so dy d theta. So what rule I need to use? I need to use the product rule, right? So I hold the first one, so it's 1 plus 2 cosine theta. Then sine theta is cosine theta. Then minus a plus, you hold the sine theta. Then take the derivative of the first one. So 1 becomes 0. 2 cosine will be -2 sine theta. All right? Okay. So -2 sine theta, and then the bottoms here, the x here. So you do the same way, see here. So you do the product rule. So hold the first one, 1 plus 2 cosine theta. Cosine theta will be what? Negative sine theta. right? Then plus holding the cosine theta, then times the derivative of 1 plus 2 cosine, so it will be negative 2 sine theta. Okay, so now with the pi equal to theta equal to the pi over 3 here. So when the theta equal to pi over 3, then you just plug in the pi over 3 for here. So if you plug in the pi over 3, so that means every theta is a pi over 3, pi over 3, pi over 3, pi over 3, right? And then use the special angle in the unit circle. So finally, the answers after simplifies here, I will get 2.2 minus 3, negative 2 square roots of the 3 minus the square roots of the 3. So it will give me the negative 1, 3, the square roots of the 3 negative. So I got a positive. So my answer will be the square roots of 3 over 9 here. Okay, so this one's here, you know, after you do that, you just plug the theta, whatever the theta, and then use the unit circle to find those special values here. So those are pretty easy, right? So the key things here is you use these two, x equal to the r cosine theta, y equal to the r sine theta, then use either product rule, quotient rule, or the whatever the derivative rules you learned, and you try to find the derivative. So it's pretty straightforward. Okay, so now the next one is here. Let's take a look. You know, find the points where the tangent line is, where the tangent line is horizontal or is vertical here, right? So it's a horizontal or vertical here. Okay, so now let's do the same ways here. All right, so like we said, x equal to the r cosine theta. Okay, so x equal to the r cosine theta. So r equal to sine theta, so it's sine theta, cosine theta, correct? Okay, then the y is equal to the r sine theta. Okay, so y is equal to the sine theta times the sine theta. So will be sine theta square. Okay, so find the horizontal, right? So find the horizontal. So I want to do the dy d theta. I want to set this one equal to 0. So the dy d theta, so you use the power rule. So this is 2 sine theta, sine and chain rule, you got a cosine theta. Then this one is sine 2 theta equal to 0, right? So for the sine 2 theta equal to 0, all right? So now we will have a 2 theta equal to 0 over pi, correct? So okay, so the 2 theta equal to 0. So we have 2 theta equal to 0 over pi. So now I have a theta equal to 0 and the theta equal to the pi over 2 here. Okay, so now, okay, so this is my horizontal, right? So, okay, so this here. Now let's do the x here, right? So the dx d theta. Okay, dx d theta here. Okay, so this is the sine cosine, right? Okay, so let's do the product rule. So sine, so this will be cosine theta times cosine theta. Then plus, you're holding the sine theta, take the derivative of the cosine, so will be the negative sine theta. Right, from here to here is the product rule. All right. Right, so now in here you will have a cosine theta square minus sine square theta equal to 0. So what is that? So what is that? That will be the cosine 2 theta equal to what? To 0, right? So that means 2 theta will be equal to pi over 2 and 3 pi over 2. So let's go ahead. I will have the theta is equal to the pi over 4 and 3 pi over 4. Okay, so now we take a look here. This is my what? This is my, the vertical. And then you see, there's no repeat, right? When I mean repeat, that means there's no angle to make the dy d theta equal to 0, and the no angle make the dx d theta equal to 0. So then I can know, so I have a horizontal tangent. So from here, I can know I will have a horizontal tangent at where? At the pi equal to 0. So when the pi equal to 0, what is your r? Right, so you substitute. So from here to here, you substitute to the function r equal to the sine theta. So my horizontal tangent will be at the points when theta equal to 0, r equal to 0. So it's 0, 0, right? So when the theta equal to pi over 2, then the sine is 1, right? So this is 1 pi over 2. All right, so remember, right, in the polar, we put the polar coordinate is r and the theta, right? So we'll put r in the front here. Okay, so here the same way, we will have the vertical. We're going to have a vertical tangent, right? Points at the points here, right? Theta pi over 4, then you substitute to r sine theta also. So when the pi over 4, what is the sine pi over 4? 1 over square root of 2 over square root of the 2 over 2 and the pi over 4. Then you do the same thing for the 3 pi over 4. So it's the same thing as the square root of the 2 over 2. Then this is 3 pi over 4. Okay? All right. Let's take a look at other ones here. So the procedure is the same here, right? So this one we need to be a little bit careful here. All right. So here, just like we did before, well, let's do the x r. So r cosine, so it's 1 minus the sine theta cosine. And the y equal to the r sine, so it's 1 minus the sine theta sine theta. Then let's do the horizontal first, right? So we do the dy d theta. So the dy d theta, after you get here will be cosine. You do a little bit of combination, like a combined term. So we have 2 sine theta equal to 0 here, right? So we will have here this term equal to 0 and this term equal to 0, right? So this term equal to 0, cosine theta equal to 0. Where is this term? We have the pi over 2 and the 3 pi over 2. So for the 1 minus 2 sine theta equal to 0, that means the sine theta equal to what? 1/2. So where do we have here we have the pi over 6 and the 5 pi over 6. All right. Okay, so this is okay, so let me write into a different color. All right, so here, so I know this will be pi over 2, 3 pi over 2, pi over 6, and the 5 pi over 6. All right. At these 4 points, I'm going to have the horizontal tangent. Okay, let's do the same way here, right? So the dx d theta. Okay, dx d theta, after you do the derivative, the product rule combined, you will get this 2 sine theta plus 1 and the sine theta minus 1 equal to 0 here. Okay, so now for this one here, we said this one will be equal to 0. So sine theta equal to 1, or this one equal to zeros here, right? So that means sine theta equal to -1/2 or sine equal to 1. When sine equal to 1, I got a pi over 2, right? So when the sine equal to -1/2, I have a 7 pi over, let me use different color here. So I have a pi over 2. Then when the sine theta equal to the -1/2, I have 7 pi over 6. 7 pi over 6 and 11 pi over 6 here. All right, so be very careful here. So these are the 3 angles I'm going to have a vertical tangent lines here, right? So did you see what happens here? Oh, pi over 2 and the pi over 2 both happen in the horizontal and the tangent. So which one it is? Okay, so what can I do? Well, let's take a look at this here, right? So let's say here, when you say when the limit theta, let's take a look at when the limit approach to pi over 2 to the from the left hand side. Let's take a look at dy d theta over dx d theta. What is this value? Okay, is the approach to 0 or approach to infinity? So this is the theta approach to pi over 2 to the negative, right, from the negative side. Now I just put the here. So this will be the cosine theta, 1 minus 2 sine theta. And then this is 2 sine theta plus 1 times the sine theta minus 1. Okay, so if you put the theta equal to the pi over 2, what do you have? Oh, I'll be darned, I got 0 over zeros here because the cosine here, right, pi over 2, this one will give you the 0, and then in here, so this one's here, the pi over 2 is 1, this term will give you 0, so it's 0 over 0. Oh, wow, I don't know, it's 0 over 0, so if it's 0 over 0, what I need to do here? We need to do L'Hopital's rules, right? So I say limit theta approach to pi over 2 from the left-hand side. Okay, let's do the L'Hopital's rule. That means I take the derivative of the top. So product rule, so it's sine theta, 1 minus 2 sine theta. All right, then plus, so it's a minus 2 sine theta. You take the derivative will be cosine theta, right? So it's a minus 2 cosine square theta. Then the buttons here, it will be 2 cosine theta times sine theta minus 1. And then plus 2 sine theta plus 1 times cosine theta. All right. So you basically use the from here to here, right? You use the L'Hopital's rules, right? Okay. So now let's try to see here. So what I have here. So when the pi over 2, this will become 0. So this is become 0. This is become 0. But here, pi over 2 here, for this number here, this will be 1. Then this will be 1 minus 2. So this one is not equal to zeros, right? So you will have like a 1 over 0. So that's why it's kind of go to the infinities, right? So if you care about, if you take a look at the different sign, this will give you the negative infinity. So I know the pi over 2, right? So has to belong to what? Belong to here, right? So pi over 2 has to belong to here, okay? So now that's why I can write here. So cannot be the horizontals, right? So the horizontal tangent going to happen at 1/2 pi over 6 and 1/2 5 pi over 6 and 2 3 pi over 2. So I only have 3 points. Then here I have 3 points also, right? So I have 3/2, 7 pi over 6, and I have 3/2, right? 11 pi over 6. Then I have 0 and pi over 2. Okay, so be very careful, right? So this is our answers here. So this is the points have vertical tangent. This is the point, the horizontal tangents here. Okay, so the lesson learned for this example is very important here, right? So the important part is here is after you find where the could be the horizontal tangent, where could be the vertical tangent, then you double check to see if there's any angle happen to be both. So which one these angles belong to, right? So that's why you want to do a limit to see is this limit when the theta getting closer to the pi over 2, it will be approach to to like 0 or to infinities here. All right, so that's it. Okay, so like the previous example, we did not see that because they have different points here. All right, so be very careful about this. All right, nice to talk to you about this interesting topic here. The next video, we're going to talk about the area. Okay, how to calculate the area. All right, that's it. Have a good day. Okay, bye.